Feed line losses. Common sources of feed line loss are water intrusion into the coaxial connectors, because that's going to screw you up. It's going to do all kinds of problems. Water in there is going to probably cause, well, you're going to get corrosion, but the water in there is going to also cause, it's a conductor, and it's going to short them possibly. High SWR, okay, that'll cause feed line losses. Multiple connectors in a line, you don't want any more than you have to have.
A loose connection in the antenna or feed line can cause erratic changes in SWR. If you see that on your meter, and I have a meter up here, this is a nice SWR meter, you'll see two needles on there, one for forward and one for reflected. Where they meet, you find your SWR. So you're seeing forward and reflected at the same time, and it's an easy way to check your SWR. So if you see it bouncing back and forth and getting erratic, that's usually a bad connection. You've got corrosion in there. Sometimes you'll just see your SWR high for no particular reason, or maybe it's creeping up, you know, a little bit at a time. That could be corrosion happening in the antenna.
Or just water incursion.
Yeah. So the feed line can also contribute to the accuracy of your SWR readings. If you have a lot of coax out, your SWR is always going to look better, just because of the loss in the line, even at low frequency. Just know that and expect that the SWR is worse than what you're actually seeing if you've got a lot of coax. So the higher the transmission line loss, the more the SWR will read artificially low. So if you have high loss on the line, like corrosion, water in the line, whatever, the SWR will look fine. Hey, a dummy load looks fine.
Yeah.
It doesn't transmit very well, but a dummy load is, you know, a 50 ohm load. So keep that in mind. Monitor the SWR meter. Also, where do you put the SWR meter matters.
Certainly.
You've got an SWR meter in your transceiver, and that position in the transceiver only measures the SWR from the transceiver, not further down the line on the antenna. Using an antenna tuner, they're talking about a manual antenna tuner, not automatic. You start with low power, make adjustments on the tuner until the minimum SWR is achieved. Well, that's easier said than done. Unless you have some idea of what you're doing, you'll fiddle with the knobs and you won't get very far. Start with both your variable capacitors at neutral, so that it'll indicate straight up.
At zero.
At 0 or 50 sometimes. And then adjust your inductor. It'll be either a roller inductor or a switch that switches out different points on the inductor. Get that one as close as you can, and then start with one and then the other of the capacitors until you get it right.
Okay, on the inductor, when you're adjusting that, listen to the static. You set your radio to the frequency.
That's the first thing.
Yes, listen to the static. When you get the highest static on the frequency that you're looking for on the inductor, then you can tune the two capacitors.
Right.
It acts like a noise bridge, and that noise is important to you because it's receiving more data.
Yeah. It's just saying that receive and transmit are reciprocal, that they're the same. So if you get the strongest signal on receive, you're probably going to have the strongest signal on transmit. So tuning up a tuner, getting the tuner matched, is easier done on receive. Get the strongest signal you can on the tuner while you're in receive, and then switch over to transmit. The impedance of the antenna is transformed to more closely match the impedance of the transmitter. All you're doing is matching.
If you're trying to tune your radio to a certain frequency and you're just trying to listen to something to test it, can you just use a handheld in your house?
No, you don't need a signal. You can actually just listen to the static
Okay.
in the background.
It's mostly on HF.
Yeah, we're not talking about an HT level system.
So to eliminate SWR in the transmission line, the antenna feed point impedance must be matched. So matching network must be located at the antenna. Well, not necessarily. I don't buy that must be located at the antenna.
Must is the wrong word.
Ideally, it's located at the antenna, because then you don't have any losses, or you don't have as many losses on your transmission line. But it's not always practical. Matching is often done between the transmitter and the transmission line. It's just more convenient to have it in the house. It does not reduce the SWR on the transmission line, correct? And all it's saying is that, you know, people assume that it's taking care of all the losses when you've got your transmatch matched up, and it doesn't. It's matching the entire system, not just the antenna. It's matching everything. All feed lines dissipate some of the power as heat. Loss is expressed in dB per 100 feet at a specific frequency. So if you look in the back of the ARL antenna book, it's got a nice chart that shows dozens of different coax types. And it'll have a line that you can find and intersect at different lengths of transmission line and at different frequencies so you can find the loss.
And if you don't happen to have the ARL handbook handy, go out on the internet and just type in RF cable loss chart.
Yeah, okay, it's online.
And it pops right up.
Smaller
And-
cables generally have higher loss. So RG58 has higher loss than RG8. Resistance of conductors. So feed line loss can be resistance, absorption by insulating material. Air or vacuum is the lowest loss, but it's also got issues. The problem with air, hard line, you'll hear that expression, hard line, is very stiff. On the outside, it's a metallic, and it actually is like a flexible tube.
Like a coax.
On the inside, there's a single connector, single conductor up the middle, and it just has a spiral of insulating material that spirals around to keep it away from the outside sheath. That works great, except anything with an air insulation is going to change air pressure and temperature, and that pulls in moisture. So it has to be sealed extremely well or pressurized with nitrogen or some other neutral gas. Teflon is a great insulator. It's used in a lot of antenna applications. So some of your PL259 connectors that you buy online, they'll advertise it uses Teflon as the insulator. Polyethylene works, but as you go up in frequency, it has a higher loss. Sections of transmission line called stubs can also be used to match impedances. You make a stub from this kind of stuff at the feed line, so you're adding some capacitance, making a match. Antennas have a characteristic impedance. So what's impedance? Impedance is resistance at AC, and it's RF resistance. So each antenna has a characteristic impedance depending on its design. It's expressed in ohms, common value is 50 ohms, and it depends on the design, the height above ground, because the higher and lower you are, usually the impedance is going down as you come down in height, and the distance from the surrounding obstacle. That can be important. I didn't realize how important that was until I did a lot of mobile stuff, and my mobile antenna would be up in a branch or something. It'd be, you know, just barely touching the leaves. Touching the leaves, right? Yeah, it matters a lot because it was always right at the tip. That was the high voltage point, and oh man, it would screw the SWR so bad. You got to keep the end of your antenna away from all that foliage.
So if you start with an antenna analyzer, it works pretty well.
And antenna analyzers can be kind of spendy depending on what you buy and if it's new or used.
Borrow it.
Yeah.
It's not something you have to own. You just borrow it when you need it.
So you put up an antenna, call one of us, and we'll help you see
Yeah.
where you are to get things tuned right to get you started.
So it can also depend on the frequency of operation. Yeah, you get away from your design frequency.
Yeah.
A quick review of the previous concept: impedance. Antennas include characteristics of capacitors, inductors, and resistors. So an antenna can be like any of those or all of them together. The combined response of these component parts with alternating currents and radio waves is called impedance. Questions before we go on? Okay, go ahead. Going on to questions now. Which of the following should be considered when selecting an accessory SWR meter?
I think all of these alpha.
Yeah, alpha.
Is it alpha?
Yeah. What they're suggesting here is, okay, you're going to buy a meter. What are the limitations? What's going to get you to purchase the right meter? there are meters that are specific to HF, some that are specific to VHF. Can you turn that off?
Hit the power button one time.
Got it.
They'll find the power button.
So, SWR meters have different design internally to handle VHF, UHF. And they're more of a strip line design where the connections are short and very direct. With HF, it doesn't matter. It doesn't take much to do with that HF SWR meter. So, you need to know the frequency, the band, and the power level. Some of them are low power, some will handle all the way up to 2,000 watts. That's why.
Those are the only two factors when selecting, and this question is a little on the goofy side, the way it's worded, because they're actually talking about what do you need to know to pick an SWR meter, and that's it. It has nothing to do with your installation,
Yeah.
other than what transmitter, what frequency, what power level. That's it.
Which of the following is a resonant or tuned circuit?
Alpha.
Alpha. An antenna is similar to an inductor and capacitor in series or parallel. Where should an RF power meter be installed? Probably not in the power supply cable.
Alpha.
Alpha. In the feed line between the transmitter and antenna. What reading on an SWR meter indicates perfect impedance match between the antenna and the feed lines.
Charlie.
1-to-1. Because SWR is a standing wave ratio. If the ratio is 1-to-1, you got it. It's a match.
Not gonna happen much though.
That's true.
What does an SWR reading of 4-to-1 indicate?
Alpha.
Delta, impedance mismatch.
And it is, but it's only to certain degrees.
So how much are you losing at 4-to-1? About a half of your power.
Yeah, yeah.
Almost half.
And as far as your radio is concerned, you don't want that much energy coming back into your radio.
Right. One of the things I want you guys to take home with you is what the SWR reading versus loss actually indicates. The 1.5-to-1 SWR, which people say is a disaster. I've heard that said exactly those words, and it's wrong. 1.5-to-1 is only a 4% loss. Who cares? Your radio won't know, nor will the guy on the other end. So 4% loss, just ignore it. 2-to-1 is 11% loss. Now we're getting up to the point that you need to at least pay attention. It probably will not hurt your operational efficiency. Pay attention because something's happening here. 3-to-1, now things are getting pretty dicey here, 25% loss. That's time to shut this thing down and figure out what the heck's going on. 4-to-1 is at 48%, and you're way past where you need to shut it down.
Yep. What happens to power lost in a feed line? Charlie. Converted into heat. Most modern transmitters will automatically shut down
Yes.
and reduce its output power to save the final transistors. So even though you might have high SWR, it probably isn't hurting the transceiver, but you're not getting much out. So it's a double hit. You're not only losing power, you're losing efficiency at 4-to-1, say, you're losing half your power. But the transceiver automatically sees that and cuts the power back some more. So maybe now it's only outputting 10 watts, and only half of that's getting radiated. Yeah, when the fan comes on, it says things are getting hot, the transceiver is already working too hard. What is the benefit of the low SWR? What do you think? Bravo? Alpha? Bravo. Reduce signal loss. Reduce TV interference? Really?
Not too much.
Yeah, it's really not going to affect that. Less antenna wear? I've never seen that. You know.
Wear out your antenna. The only thing wear out your antenna is wind.
What's the most common impedance of coax cables used in amateur radio? Bravo. 50 ohms.
And one of the things that kind of amazes me on that question right there is why isn't 72 ohms on that? It should be, as a detractor.
Yeah.
72 ohms is so common in the television and video world that people use it all the time, and you can use 72 ohm cable in amateur radio. You just have to be careful how you match it up. It will work?
Yeah. I've got some up here, RG6, 72 ohms. Actually, a dipole strung out horizontally is 72 ohms.
Yes.
Close to it, 70 ohms at the match, at the feed point. Why is coax cable the most common feed line for amateur radio antenna systems? Alpha. It is alpha. So this kind of feed line works wonderfully. Great stuff. Except that it's difficult to feed in through a window or coming through a wall because these two connectors, these two conductors, have to be free from close proximity to other objects. It's very sensitive to that. Okay, you can sort of make that work. I know guys who do, but it's difficult.
Depends on your installation, what you're working with, where your house is, where your jack is, where your antenna is.
Well, you use twin lead,
Yeah.
and then you go from twin lead to coax.
Yes. And the coax goes through that wall into the house. So you can do it, it's just how the antenna is designed.
What happens as the frequency of the signal in the coax cable is increased? We talked about what kind of coax to use when you go up to UHF.
Delta.
Delta. The loss increases when the frequency increases. So what could cause erratic changes in SWR? A loose connection in the antenna or feed line. Which of the following types of feed line has the lowest loss at VHF, UHF? Think about it. Remember there was a statement in there that you said was at yellow. Air insulated hard line. And remember that's what they use for microwave. So going up higher and higher in frequency, you need air insulation. What's the standing wave ratio?
Charlie.
Think about that. Transmitter efficiency ratio?
Mystery. Alpha.
Alpha. So how well the load is matched to the transmission line. Doesn't have anything to do with the amplifier power output. And yeah, the transmitter will fold back the power when the SWR is high, but that's an internal thing with the transmitter. It's not.
All of them don't have that.
Yeah, and that's also not the definition of SWR.
Right.
Which of the following is used to determine if antenna is resonant at the desired operating frequency? An antenna analyzer. So you could use just an SWR meter or a power output meter and go through the long process of figuring it out, but an analyzer makes it easy. Which instrument can be used to determine SWR? Directional watt meter. You're figuring out the SWR with a watt
That's what
meter
this is, basically.
because you get both reflected and output power. From those two, you can calculate SWR. Which of the following causes failure of coax cables?
Alpha.
Moisture contamination. What about the others? What is solder flux contamination?
You got dirt in your flux.
Why should the outer jacket of coax cable be resistant to ultraviolet light? Ultraviolet light can damage the jacket and allow water to enter the cable. On most cables.
Almost all of them are UV resistant now, aren't they?
Almost all of the coax now is stabilized with ultraviolet.
And some cables, RG213 specifically, are actually designed to be buried directly. The jacket on RG213, it's just an RG8 cable, okay? But it has a jacket on it that is military equivalent and ready to be buried.
What's the disadvantage of air core coax cable when compared to foam or solid dielectric types?
Charlie.
Require special techniques to prevent moisture in the cable. Either pressurized with neutral gas, dry gas, sealed really well. Which of the following types of solder should be used for radio and electronic applications?
Alpha.
should not be used for radio.
Yeah, the keyword there is no.
Oh,
Yeah, I think I missed that. What is the characteristic appearance of cold tin lead solder joint? So you've made your solder connection, and how do you know it's a good solder connection? A rough, lumpy surface is what you're looking for. If you don't get the connection hot enough, it will look kind of rough and lumpy. What's the major function of an antenna tuner or an antenna comp?
Alpha.
Alpha is correct. It matches the antenna system impedance and the transceiver's output impedance. Which of the following RF connector types is most suitable for frequencies above 400 megahertz? So now we're talking UHF,
Problem.
type N connector. A UHF just, it'll work, but you're going to have some SWR issues. Which of the following is true of PL259 type coax connectors? So here's your standard UHF, and not a UHF connector.
Alpha.
Which of the following is true of PL259s? They're commonly used in HF and VHF. So it is weird, when you look these up in a catalog, they will be called a UHF connector. And that goes way back to World War II when they were designed. Back in World War II, 2 meters was UHF, but it's not anymore. And these connectors really shouldn't be used in UHF.
And so when you go to buy an antenna, you want to look at the connector on the antenna. You may have to put an adapter on it if you're going to use in connectors, or if you can buy the antenna with in connectors and you're going to use LMR 400, then you're going to cut down on the loss that you have in the system. But
Yeah,
you can't
and
always
you
get.
can get away with them. It's not that they can't be used at UHF, but they are more lossy. You kind of juggle it. If you're going to have more than a couple of connectors in the series, you probably want to go N. If not, you can get away with it. Which of the following is a source of loss in coax feed line? All of these choices are correct. Multiple connectors are a source of loss, high SWRs obviously, and water intrusion. What's the electrical difference between RG58 and RG213? What's the electrical difference? Do they both 50 ohms? Yeah, they're both 50 ohms. Charlie is correct. So you go bigger cable, you're gonna have less loss at higher frequencies. What's the purpose of an antenna tuner? Increase the power transfer from the transmitter to the feed line. So why don't they say reduce the SWR in the feed line?
Because it doesn't.
It doesn't reduce the SWR in the feed line. It reduces the SWR in the whole system.
To an acceptable level for your transmitter.
Yep, to the transmitter.
And realistically, I don't like this answer either, because it doesn't increase power transfer. It just makes it more acceptable to the transmitter.
Which of the following factors determine the characteristic impedance of parallel conductor feed lines? Alpha. So the distance between these conductors and the thickness of the conductor itself is what changes that impedance.
So the coax, even though it's got a insulator between them, it's still closer, and that's what causes it.
Sort of. So these all have 50 ohm impedance, and that has more to do with the radius of a.
That's what I'm saying.
Yeah.
It's like an insulator around, as opposed to air between the two.
There's more physics in it than that. What is the relationship between high standing wave ratio and transmission line loss?
Problem.
High SWR increases the loss of velocity transmission.
Is that Southern Oregon terminology there?
No, that's actually basic RF. You'll find that term all over the RF world, yeah. What we're dealing with here really is not transmitters at all. We're dealing with receivers. Because the signal levels at received conditions are so tiny, you can't afford to lose any.
Right.
So that's what we're actually after when we're trying to tune that thing for the best transmission. We're tuning it for the best receive frequency system. That's our ultimate goal.
Okay. What's the nominal characteristic impedance of window line transmission? Okay, that 450 ohm line I held up. That's window line. And I just mentioned what the,
Would it be delta?
Gee, what a surprise.
450 ohm.
Would it be?
What causes reflected power at an antenna's feed point?
Charlie?
Yeah, Charlie. A difference between the feed line impedance and the antenna feed point impedance. So then you're going to have a ratio, and that ratio is your SWR. Feeding the antenna with unbalanced feed line, what does that do? Well, what is balanced feed line? This is balanced feed line. It's got two conductors, exactly the same. And the signal is doing this thing, going all the way up. That wave front is collapsing on itself, going back out and collapsing on itself, and it stays inside that transmission line because it can't come out. It's balanced. When you get close to a metal object, it's no longer balanced, and some of that leaks out. With this kind of coax, it's all contained inside, but it's unbalanced. It's not a balanced line. So you have a balanced antenna fed with this stuff, unbalanced. What happens? Signal goes out, comes back. Part of it ends
Gets
up on the
confused.
outside of this line, coming back down the coax as stray RF. That's what bites you from the microphone. We need some way to keep that RF coming back down the coax. So we use a balanced to unbalanced up at the feed point. It could be a simple choke. It could just be a coil of wire, about 4 inches diameter, wrapped tight, about 6 or 8 turns. Put wire ties around it, and that'll keep that RF coming back down the coax. How does the attenuation of coax cable change with increasing frequency? This is attenuation.
Attenuation is the same as loss.
Attenuation is loss.
Bravo.
Attenuation increases as frequency increases. That's true with all coax. In what unit is RF feed line loss usually expressed? In what units is RF feed line loss usually expressed?
Delta.
Decibels per 100 feet. What must be done to prevent standing waves on a feed line connected to an antenna? When we're talking about SWR being too high and standing waves coming back and forth in the feed line, how can we prevent that?
Delta.
The antenna feed point impedance must be matched to the characteristic impedance of the feed line. Get it matched, no SWR. If the SWR on an antenna feed line is 5 to 1, and the matching network at the transmitter end of the feed line is adjusted to 1 to 1, what's the resulting SWR on the feed line? Remember that tuner is not changing anything in the feed line. It's making the transmitter look into that feed line and match.
Bravo, right?
Bravo.
Bravo. It's still 5 to 1. Okay? So the advantage, if you got maybe your particular lot, you got a long lot. I had an acre in Texas. I had 200 feet of coax underground going out to the tower, and then another 80 feet going up the tower. Well, I had a lot of line out there. I had to pay attention to what was going on, and I kept the number of coax connectors to a minimum. I used good coax, and I kept the SWR low. What standing wave ratio results from connecting a 50 ohm feed line to a 200 ohm resistive load? It's just a ratio, 50 to 200. What's the ratio? 4 to 1.
Small.
It's always expressed as the larger to the smaller. Yeah, 4 to 1. Just divide one into the other. What standing wave ratio results from connecting a 50 ohm feed line to a 10 ohm resistive load? 5 to 1. What is the effective transmission line loss of SWR measured at the input of the line?
Bravo.
I hear a problem. Higher loss increases SWR measured at the input to the line. Higher loss reduces SWR measured at the input to the line. Why would that be?
Because there's nothing in the line that's decreasing the strength of it.
So the,
I mean, it hasn't traveled.
basically the transmission line is acting like a dummy load. If it's got high loss, it's still 50 ohms, and the loss is absorbing a lot of that energy and making it look like a dummy load. A dummy load looks great. So it tends to mask higher SWR in the antenna. Makes the antenna look better than it is.
It's the artificial input, right? So it's making it look artificially lower, better.
Yeah.
Yes, so it protects your radio is basically what it's doing. You're gonna get less power transmitted. That's the other side. It protects your radio, so that's the most expensive part.
What is the interaction between high standing wave ratio and transmission line loss?
Bravo.
Bravo. Bravo, bravo. If the transmission line is lossy, high SWR will increase the loss. What is the effect of transmission line loss of SWR measured at the input to the line?
Alpha.
Alpha, the higher the transmission line loss, the more the SWR will read artificially low.
And you won't know that it's artificial. You'll just see a low SWR.
Yeah, so, like,
Yeah.
maybe you just purchased an antenna and you put it up, maybe for VHF. You put it up and you run the coax out, you've got 100 feet of coax, you hook it up, oh, maybe I'll check the SWR. Put a meter on that coax, it looks good. Yeah, all right, ready to go. Maybe I ought to check it at the antenna. You go back out to the antenna, oh, it doesn't look so good. In fact, it doesn't go all the way to the top of the band. Maybe I need to tweak this a little bit. Now you really know what the antenna is doing.
Right.
Before, you were getting, it was getting masked. That difference in the SWR was getting masked by the loss in the line.
And the first giveaway that that situation is happening is probably going to be, yes, your SWR reader says it's very low SWR, nobody hears you. Because there's no signal going out. Where's that signal going? It's being absorbed by a lossy transmission line.
That's a worst case, but you know, that